Alright, we're going to start doing lesson 7.3, solving equations using quadratic techniques. Another name I call this is U substitution. So hopefully we can get through this real quickly. My computer's kind of at a different level, so hopefully you guys can see this. It looks good on the screen, so we'll see how it goes. Alright. The first example, I'm just going to kind of give you this. The first couple examples, I just want to show you how to write the polynomial in quadratic form. Okay, so let's say we had, for example, we had a marker that works. Say we had 2x to the 6th plus x cubed plus 9. Okay? My goal is to get it in the form of a quadratic. So au squared plus bu plus c. I need to let u equal a particular value, and then when I square u, I get this value. So for example, the only way that u substitution works in this case is if I would let u equal x cubed, and then u squared, well in this case, if I let u equal x cubed, u squared would be the same thing as saying x cubed squared, which is x to the 6th. So u equals this, u squared is equal to this. So now I'm going to actually substitute that in. So I'd actually have 2u squared plus u plus 9. Okay, u squared is x to the 6th. U is x cubed. So substitution. So now it's in the form of a quadratic. Alright? So that's u substitution. Now there are cases where I would not be able to do this, but in this particular case I was able to. Let's see if we can't do another one. Well, let's say we had 7x to the 10th plus 6. Fairly easy. I guess all you have to really do is, in this case, you have something squared. You can let u equal. Or just let u squared. If you let u equal x to the 5th, x to the 5th, then u equal x to the 5th, then u squared is equal to x to the 5th squared, which is equal to x to the 10th. Okay, well then I don't have any u's, so I don't have to substitute what u is, but I do have u squared, or I do have a situation where I can put x to the 10th here. So I'm going to write this as 7u squared plus 6. Alright? That's just, letting you're letting u equal x to the 5th. And then when you square u, it's like if you square u, you're squaring x to the 5th. U squared is the same thing as x to the 10th. Well, so then I make u equal that value. I just rather than saying x to the 10th, I say u squared, because I have ways of solving u squareds or quadratic, this form. I don't have any methods of solving polynomials or equations like this. I don't. We haven't gone over anything like that. But when you put it in terms of a quadratic, I have methods of solving the solutions for this. And we'll get into that here in a second. Alright, so here's an example where we have to solve, okay, and notice that this one's a little tricky too, because it has rational, fractional or rational exponents, so they're not integers. The first trick is to write it in the form of a quadratic. You want to use u, or find a u to whereas when you square it, you get, this value here. So in this particular case, we kind of have to let u equal, x to the 4th, x to the 1/4, I'm sorry, and then therefore u squared is the same thing as x to the 1/4 squared, which, in this case, when I take 1/4 power of a power, I multiply. 1/4 times 2 is 1/2, so I do get x to the 1/2 here. So that's what I needed. So u is the same, is equivalent to this. U squared is equivalent to this. So that's what I'm going to write. I'm going to write, well, u is u squared in place of this minus u minus 6 equals 0. Okay? So back to the same reason before. Why am I doing this? Well, there's no way I could solve this up here. I don't have any idea how to do that right now. But if I take this thing up here and I substitute in values for it and make it equal certain things, and it follows this pattern here, it abides by the rules right here, then I can turn it into something that I can solve for. Okay, so I turned it into a quadratic and put it in quadratic form. Now, I just use my quadratic techniques to solve. All right, and then I'll show you what we have to do here in a second. So I have u and u. If I go minus 3 plus 2, I should get my, what I have up there. So there's my solutions. Now I'm going to use the zero product property, and I'm going to put, well, u minus 3 is equal to 0. So that means u is equal to 3, or u plus 2 is equal to 0, and u is equal to negative 2. Well, we're not, normally we would be done right now, and we'd say 3 and negative 2 as our solutions, but we're not quite done. Okay? We actually have a little bit more work to do, because u is not our real value. It's x that we want. So all we have to do is some substitution back in for here. Okay? So rather than saying u, I'm going to say, well, instead of u, it's x to the 1/4 is equal to 3, which I can solve for this, right? All I got to do is take both sides times the power of 4. 1/4 times 4 would be x to the 1st, or just x. 3 to the 4th is 81. I got to do the same thing over here with this value. I have x to the 1/4 is equal to negative 2. And if I take the power to this power to 4 again, what do I end up getting there? I get x is equal to 16 is what it says. Now, one of the things when we deal with fractional exponents like this, I strongly suggest that we plug those back in and we check our answer. And if we check our answer, I think this one becomes what we call kind of an extraneous solution. Extraneous solution. I think, I'm not positive, but I think it does. So, but that's how you would solve a polynomial function. You put it in quadratic form, and then solve accordingly, like we know how to do. All right. Okay. All right. So last one. Try to do it as quick as we can. Okay. So I noticed that this is x to the 4th, x squared plus 100. So just for instance, you need to kind of become familiar with what things can be written and in quadratic form. Not everything can be. Okay. But this in particular case, if I let this x squared, let's say I let u equal x squared, then u squared, which would be x squared squared, would end up being x to the 4th. So my u to x to would be equivalent to x squared. My u squared would be equivalent to x to the 4th. So this would work. So u substitution would work here. So I'd go u squared minus 29 u plus 100 is equal to 0. Alright, so in this particular situation now I just got to factor or use the quadratic formula. However I know how to solve a quadratic, that's the methods I can use now. I wouldn't have been able to done that up here, but I can do it now. I think this is factorable. I'm not really sure. Go U and U. Well, yeah, you go minus 25 and minus 4. It should give you what you need there. Now, if I take those values and I plug those, into the zero product property, I have U minus 25 equals 0. I have U minus 4 is equal to 0. U is equal to 4. U is equal to 25. Well, yeah, not necessarily. I'm not quite done yet. So now I need to substitute back in. Well, U is actually x squared. So I have x squared equal these values. And then if I square root both sides, x would equal plus or minus 5. X would equal plus or minus 2. Okay? So there's a quick lesson on solving equations using quadratic techniques. Okay? The trick is, and do a little bit of research on this if you want, but the trick is trying to get, finding your U, find a U value, and then when you square that value, you have to be able to get this value. Okay? So that's it. Alright, here's 2 try this problems that we need to try. So please attempt these and get these recorded down. A little tricky, I guess, the second one. The first one should be, fairly straightforward. This one right here, think about it a little bit. But it's both of them are, you are capable of solving them. Okay, so good luck.